Okay, question 7. We've got to give the definition of a moment of a force, and that is going to be the force multiplied by the perpendicular distance to the line of action of the force. Perpendicular. That's got to be spelled correctly. To the line of action. And the second part is we've got to look at the two conditions that apply when an object is in equilibrium, and that will be that the net force is 0 and the net moment about any point, but I think we can get away without saying that, is also 0. Okay, now we're coming on. We've got this human arm lifting an object, and in the blurb what we've got, the lower arm is horizontal and its centre of gravity is 1.5 meters from the elbow joint. The weight of the lower arm is 18 newtons. The bicep muscles exerts a vertical force of F on the arm. The horizontal distance between the elbow and the joint is 0.040 meters. The weight of the object held in the hand is 30 newtons, and its centre of gravity is 0.460 meters from the elbow joint, and the arm is in equilibrium. So let's get on to these bits. Define the centre of gravity. That's the point where the weight of the object appears to act. I won't bother writing that out. And here we go. Part 2. Calculate the total clockwise moment about the elbow joint. Okay, so here's the elbow joint. Which of these forces are going to try and make it rotate clockwise? And it's going to be that one and that one. So if we add those two moments together, so we're going to have 18 times 0.15 plus the moment from the 30 newtons, which is going to be 30 times 0.460 newtons, which comes to 16.5, which is two significant figures, because both the forces are two significant figures, so that is 17 Newton meters. Okay, now as the lower arm is moved away from the body, the force F exerted by the bicep muscle acts at an angle of theta to the vertical, as shown. The lower arm remains horizontal and in equilibrium. Describe and explain what happens to each of the following quantities as the angle theta is increased. The anti-clockwise moment about the elbow joint. Well, if we have a look, that distance there, that distance and that force, they haven't changed. So the anti-clockwise, because it's an equilibrium, the anti-clockwise moment has got to equal the clockwise moment. So the anti-clockwise moment has to stay the same as the clockwise moment, and the clockwise moment hasn't changed, so it stays the same. And then we've got to look at the magnitude of force F. Well, if we have a look at this slightly differently, so if there's my elbow joint, there's force F, and that distance there was 0.04 meters, and there's my angle theta here. When the elbow was straight, i.e. force F was pulling in that direction, then it would be force F multiplied by this, but now because the definition of a moment is the perpendicular distance to the line of action of the force, so that is now that distance there, which is a shorter distance than 0.04. So in order to keep the moment the same, because F is the moment is F times x, if x here has got shorter, then the force F has to get larger. So F increases as the perpendicular distance decreases to achieve the same moment about the elbow. Okay, there we go, that's question 7.